Congrats on reaching page 3. So if you take a look at page Roman numeral 3, this page is dedicated just to writing and naming binary formulas of compounds made of elements with variable oxidation numbers. Of course, that totally makes sense. Ish. What this really means is that we're going to be looking specifically at the elements, or specifically at problems that include the transition metals. That's really what I mean by variable oxidation numbers. You see, not all of the elements are in group 1 or group 2, where it's really easy. We've already clarified all of group 1 has one valence electron and as an oxidation state of +1. All of the elements, unless we're told otherwise, in group 17 have 7 valence electrons and an oxidation state of -1, right? Those are really easy. But when we start to look at the transition metals, we don't really have an unless we're told otherwise, right? It's kind of vague. So we're going to take a look at an example of the transition metals and figure out how to do this. Now, the biggest thing with this, so go ahead, turn to page 3. We're going to take a look at number 2 together. Nickel 3 and chlorine. Okay. Now, one of the biggest things is you always have to start by asking yourself the question, do we have a metal? If we have a metal, then we can use the stock system because it's a special type of bond. What type of bond is it? Great, so this is an ionic bond between nickel 3, and chlorine. Okay, now in this problem you're given some more information than you think. This nickel 3 is actually telling you the oxidation state of that nickel. Okay, this here in the parentheses is the oxidation state. And this is why I keep the skeleton system the way it is. Because if you notice, that 3 is in parentheses, which tells me it must be an oxidation state. So because I'm given the oxidation state, I can just throw that number right down here. Now you'll notice I put a positive in front of that 3. That's because I know nickel is a metal. I know it's a metal and I know it's a transition metal. It's right here on the periodic table, right? Or to look a little bit closer, if we look at this guy, nickel's way over here. Now, as I said, group 1 has an oxidation state of +1, and group 2 +2, right? And then +3, and then -1, -2, -3, plus or -4, right? Because group 14's just like doing its own thing. And then here we have like 0, because the noble gases are all snooty and they don't want to deal with anybody, but whatever. But here's nickel, okay? In our transition metals somewhere between +2 and +3, and we don't really know what it is. Okay, now all of these have different oxidation states. You'll notice that some of them, like iron, have more than one option for the valence charge, right? In this periodic table, nickel has 1, but for the sake of our example problem, we're going to stick with what we're given in the problem, okay? So let's go back to this. We have nickel 3. So I can go ahead and plug in, I'm going to change my color here so it's a little bit easier to see, +3 for the oxidation state for nickel. And for chlorine, well, I know that chlorine is right here on the periodic table, right? It's within that group of halogens with a -1 valence charge or oxidation state. Well, now I just do the same exact thing I did before. So I need to figure out what numbers would go here and here to give me 0. Now, I'm not actually going to put 0 here. Remember, I can't have 0 nickel atoms and 0 chlorine atoms. Instead, the numbers that probably would work out are 1 and 3. Remember, I can't have a negative 3 because that wouldn't work out for me. I can't have a negative number of chlorine atoms. So we're going to go ahead and do this real quick just to double check our math. I have 1 times positive 3, which gives me a positive 3, plus 3 times negative 1, which gives me negative 3. And indeed, 3 plus negative 3 gives me 0. That checks out. I end up with 0 net charge if I have 1 nickel atom and 3 chlorine atoms. So I would write this out as Ni, and I only need one of those, Cl3. That's my written form of nickel 3 and chlorine. Now, the most common mistake, I'm going to even do this in red. Don't do this. People look at this nickel 3 and they say, oh, well, that's got to be Ni3Cl. But that's wrong, because that 3 is not the number of atoms. That 3 is the oxidation state for nickel. And that's why I keep that in parentheses. Okay? Now, all we've done so far is write out the actual formula. The name is just like we did the binary formulas from before. But this time, we need to include that 3. So I'm going to write this out. Nickel, and I'm going to include my parentheses, 3, chloride. I'm adding that IDE on before, or on the end of it, just like before. And chlor is the root part of chlorine, right? So instead of INE, I change that to IDE in my name. So nickel 3 chloride, that 3 being the oxidation state of nickel. Okay, so now that we've done an example together, you can go ahead and try the rest of page Roman numeral 3 of your packet. Come up, check your answers, and again, you must show all your work. And then you can go on and watch the next video. Good luck!